Today we're going to be talking about square roots. So I want you to think about a root in general. Who can tell me what a root is or what a root does? Sherelle.
Connects the tree to the what?
It connects a tree to the ground? Okay, yep, that's a root. What else? Mm-hmm.
Well, it keeps the tree standing up.
It keeps the tree standing up. Yep. What else?
It gets nutrients for the tree.
It gets nutrients for the tree, okay? So it helps a tree out, all right? It's the base of a tree, okay? Who can think of something that has roots?
Me.
Our hair. Plants. Our hair.
Plants, okay? What kind of plants have roots? Flowers?
A tree. Leaves. Shrubs.
Shrubs, okay? These things have roots. Once again, you mentioned things that they do. They bring up the nutrients. It's the base of what the plant or the tree is. So today I'm going to be teaching you about square roots. It's basically the root or the base of different kinds of numbers, okay? So let's go ahead and write this down. This right here is talking about perfect squares. Perfect squares are numbers that are squares of integers. Remember, an integer can be something that's positive or negative, such as 1, 4, 16, and 25. So 4 right here is a perfect square because a number multiplied by itself equals 4. 9 is a perfect square because you can see here 3 times 3 equals 9. All right, now just the same thing over here, the opposite. If I have a negative 2 times a negative 2, if you remember, if I have two negatives, my answer will always be what?
Positive.
Positive. So, once again, 4 is a perfect square. It could be 2 times 2 or negative 2 times 2. Another one, 16 is a perfect square because 4 times 4 equals 16. Who can think of another perfect square? Okay, so 36 would be the perfect square because 6 times 6 is 36. What's another perfect square?
10.
Why 10? It has to be a number multiplied by itself equals 10. What number multiplied by itself equals 10? No number. Okay, so 10 is not a perfect square. What's another one that is?
49.
49. Why is 49 a perfect square?
7 times 7.
7 times 7 equals 49. What's another perfect square?
20.
20. Why is 20 a perfect square? What number times itself equals 20? No, 10 times 10 is 100. So 20 is not a perfect square.
25.
Okay, why is 25 a perfect square?
5 times 5.
5 times 5. Okay,
Thank you.
does that make sense? All right, so then another thing that I want to teach you today is a radical sign. If you look at this, this is a radical sign. It's a square root. All right, so that right there is a positive square root. But if you look at the next one right here, do you see what's in front of this radical sign? A negative. So that means it's a negative square root. All right, we'll talk more about that here in just a minute. I want you to write a little bit about a square root. So the definition here of a square root says a square root of a number is a number that when multiplied by itself gives another number. So it's almost the opposite of the perfect square that we were just talking about. The square root of 64 is, what is the number that multiplied by itself equals 64? 8, okay? So 8 times 8. So the square root for that one, we're just going to go ahead and box this in, is an 8, okay? The next one, the square root of 81. What number times itself equals 81? 9 times 9. So the square root is a 9. Square root of 36 is 6, because 6 times 6 equals 36. 6 is my square root. Last one, square root of 4 is 2, because 2 times 2 equals 4. What would the square root of 1 be? 1, because 1 times 1 equals 1. Okay, so let's do a couple practice problems. Number 1, find the 2 square roots of a number. All right, so the first one here I have says 81. What is the square root of 81, guys? 9, okay? But I have asked you not to give me one number, but I have asked for 2 numbers. So who can think of another number that would also, multiplied by itself, equal 81? Negative 9, okay? So 9 times 9 is 81. Negative 9 times negative 9 is also 81. So there's an interesting way that you can write that, so you don't have to write 9 and negative 9. It's just like this. Positive and negative 9. Okay? You can write it either way. I don't care if you write it this way or if you write it this way. Either one's fine. I'll probably use this bottom way right here for me. Okay? Do problem B on your own. Okay, problem B, 49. What is it?
Positive negative 7.
Okay, 7. And once again, because I want 2, it can be positive or negative, or positive and negative 7. Questions? All right. Number 2. Evaluate the square root. Okay, so number 2 says evaluate the square root. So tell me, what is the square root of 36? 6, okay? Now, if you remember in our notes, this kind of a sign right here, this radical sign, is my answer going to be positive or will it be negative?
Positive.
Positive. That's a positive square root. So you know your answer is going to be positive. So the answer is positive 6. Let's go on to the next one. Square root of 16. What would that be? 4, okay? Because 4 times 4 equals 16. Once again, you can see right here, I've got a positive radical sign, so my answer has to be positive. Let's go to problem C. This one looks a little bit different than problem B. What's different about it? It's got a negative right there, okay? So I am taking the negative square root. So each time, you're going to keep that negative sign. So I already know my answer will be negative, and then I can almost look at it as if this wasn't even there. What's the square root of 16?
Negative 4.
Okay, square root of 16 would be 4, but we already know my negative is there, so my answer is negative 4. Problem D, square root of 0. What number times itself will always equal 0? 0. Now the next one's a little bit bigger, all right? We've learned each of our times tables for the 6 family, the 4 family, but we haven't learned the times tables that's going to get us up to 625. So this is the time where your calculator comes in. So I want you to pull out your calculator for me. Okay, so when you plug that in, you automatically know your answer is going to be what? Positive or negative? You know it's going to be negative because there is a negative right there in front. So what's the answer, guys? Negative 25. Okay, so this is telling us to evaluate the expression when z equals 7 and m equals negative 2. If you remember, we started doing this at the very beginning of the year where I would say plug it in, plug it in. So you're making a substitution. Instead of putting 29 plus z, what does z equal? 7. So we're just going to plug it in instead. I'm going to keep writing each of my steps out. 29, instead of plus z, it's going to be plus 7. All right? So you always want to work all of your stuff underneath that square root sign or that radical sign. What is 29 plus 7? 36. So keep that square root, and now it just tells us we're finding the square root of 36. Once again, you can use your calculator, but if you already know that answer, just tell me, what is the square root of 36? 6. Okay? Now, is this going to be positive or negative 6?
Positive.
It's going to be positive, and you can see once again, because we had that radical sign right there, we know that's a positive radical sign, so our answer is going to be positive. So the answer is positive 6. I want you guys to try to do problem B on your own. Okay, so the first thing we're going to do is plug it in. Instead of z squared, what will I put? 7 squared. Plus, I want you to keep parentheses right here. What am I writing instead of m squared? Negative 2 squared plus 11. Okay, now once again, make sure you keep that radical sign there. All right, let's do all of the work underneath before I try to find out what the square root is. What is 7 squared?
49.
49. Plus, what is negative 2 squared? 4, because negative 2 times negative 2 equals 4, and then I'm going to bring down my plus 11. Once again, remember, we are finding the square root of this number. Once again, do all of your work underneath the square root sign. What is 49 plus 4 plus 11?
93.
Put it in your calculator, guys. 49 plus 4 plus 11. What is it?
64.
64. So once again, I'm still taking the square root of 64. Okay, what is the square root of 64? 8. Is it positive or is it negative?
Positive.
It's positive. Once again, if you remember, it's asking us for the positive square root of 64. So your answer would be 8. For this one, we're going to be solving the equation. Now, this is going to be exactly like all of the other problems we've had with algebra before. Your whole goal is to get what by itself?
X.
X by itself. At this point, is X alone? It's not. Why is it not alone? What's there?
That's exponent.
It has an exponent. What does X squared mean?
5. I mean,
A number times itself.
It means a number times itself, okay? So if I want to get rid of X squared, does anyone have a guess of how I might get rid of an X squared?
Divide.
Not divide it.
Multiply.
The X has a 1 in front of it, right?
The X does have a 1 in front of it, but we're not trying to get rid of the 1. That's almost like an imaginary 1. The way that you can get rid of a square that looks like this is to do the square root. Because I'm trying to get rid of one of those x's. So if I take the square root of x squared, it's going to get rid of one of my x's. Okay? Also, if I square one side, what do I have to do to the other? Okay? Or square root it, I mean. All right? So here's the deal. X squared means the same thing as x times x. 25 means the same thing as 5 times 5. When you're taking the square root of something, as long as you've got 2, you're allowed to pull one of them out. So what would the square root of x times x be?
25.
The square root of x times x. It's plain old x.
Oh.
Okay? What's the square root of 5 times 5?
25.
No.
5.
5. Okay? When you take the square root of a 25, you get just a 5. Okay? So, here's the interesting thing though. I was the one who added that square root in. Anytime that I am the one who introduces the radical or puts the radical into a problem, every time you'll have 2 answers. So not only is positive 5 an answer, what do you think the other answer is? Negative 5. Positive and negative 5 is your answer. And here's why. I can take this and plug it back into my original. My original said x squared equals 25. Could I have positive 5 there? 5 times 5 equals 25? Yes, I could. Could I have negative 5 times negative 5 equals 25? Yes. So every single time that I am the one who introduces the radical to the problem, there will always be 2 answers, a positive and a negative. So let's go on to the next one, problem B. H squared plus 5 equals 54. Who has a guess of what you think I should do first?
Turn it into a negative. Turn 5 into a negative and minus 54.
Okay, I want to get rid of that plus 5. If you remember, we can do the opposite and get rid of it. So the opposite of plus 5 is minus 5. Okay, so if I subtract 5 to the left side, I have to subtract 5 to the right side. This cancels out. I'm left with h squared equals, what's 54 minus 5? 49. So now I've got a problem that was similar to problem A. Is h by itself right now?
No.
No, it's not. There's still a squared there. H squared is still there near it. How do I get rid of h squared?
Do the thing that you did.
What's that thing called?
Square root.
Do the square root of it, okay? So I'm going to take the square root of h squared. If I take the square root of the left side of the equal sign, I have to take the square root of the right side of the equal sign. What is the square root of h squared?
H times H
H times h, okay, but what's the square root of that?
equals 7.
Just plain old h, okay? You can show me the step that it equals h times h. If you know that, you don't have to show it to me. I wanted to at least explain it on the first problem. What is the square root of 49?
Square root
7, okay? Am I done?
No.
No. What else is my answer? Positive and negative 7. Remember, once again, if I am the one who introduces the radical to the problem, I brought that radical sign in there. That means it could have been a positive or it could be a negative. Every time that we introduce it to the problem, there will always be a positive and a negative answer. All right, this is gonna be the last problem of the day. M squared plus 31 equals 112. I want you guys to try to do it on your own. I am looking for the first person with the correct answer.
Wait, what does that have?
All right, we got half of you definitely have the right answer. The first thing, my goal is to get M by itself. What should I get rid of first, my squared or my plus 31? Always get rid of the things that are not attached to the variable, okay? So in this case, that square is attached to the variable. So we're gonna wait till the very end to get rid of that, all right? So how do I get rid of plus 31?
Minus 31.
Minus 31. I have to be fair and do what I do to both sides. This cancels out. I'm left with only M squared equals, what's 112 minus 31? 81. My goal now is to get M by itself. Is M by itself?
No.
It's not. What's not letting it be alone?
2.
The square. Okay, don't just call it a 2 because we're not multiplying 2 or adding 2. It's the square, all right? How do I get rid of the square? Take the square root. If I take the square root of one side, I got to be fair and take it to the other side. What's the square root of M squared?
9 times 9.
M
Oh.
M. What's the square root of 81?
plus or minus.
Okay, we know that it's 9, and since we are the ones who introduced the radical to the problem, the answer is going to be positive and negative 9. Once again, I want you to check it out and put this back into the formula up here to see if it works. What's 9 squared?
81.
81, and then add 31, what is that?
112.
112, and that is the answer that we had there. Now let's check it one more time. That was the positive 9. What about when I plug a negative 9 into there? What's negative 9 times negative 9?
81.
Still 81 plus 31,
Oh.
112. So it did work out, okay? That's how you do those kind of problems. Tonight you've got 10 homework problems from 11.1. So go ahead and pull out a piece of paper and write this assignment down for me, please.